Hello everyone, welcome back to the channel. Today we will be doing question 15 of chapter 6, that is application of derivative. So if you are interested in this question, take your book and pen and let's begin with the question. The question is, show that the altitude of a right circular cone with maximum volume is 4r by 3. So we want to first show that the volume is maximum and then show that the altitude of the cone is 4r by 3. So let's take a sphere and let's put a cone in this sphere. Now the radius of this sphere is r. So both of this will be r. We are going to take this, say BC as h and CD as the radius of the cone, which is capital R. Okay. And we know that it is a right circular cone, that is why angle C will be 90 degrees. So from here we have one thing, that R square, that is the radius of the sphere, is h square plus capital R square, and that the height of the cone is, say, capital H, which is h plus r, which is AC. Now we have defined the dimensions. Let's start with the volume of the cone. So volume of cone is, say, V, which is 1 by 3 pi r square h, and from here capital R square is r square minus h square and h is h plus r, the height of the cone. Let's simplify this, and remember here small r is constant because that is the sphere radius which is given to us. So this is going to be a function of h. We want to maximize the volume. We'll have to find f dash h, critical point, and then look for maximum minimum using f double dash h. So let's first find f dash h. Differentiate this. R being constant, it is r square into 1. This will be 0. Simple derivative. H cube is 3h square and h square is 2h. R is constant as it is. So r f dash h, if we rewrite it, becomes like this, and for critical point let us take f dash h to be 0. So this is a quadratic in R, you can think it like that and solve it, or a quadratic in h. So we have 3hr plus hr, that's what splitting middle term we have done. So the value of r will be either minus h or 3h, or rather we are finding value of h. So h will be minus r, which is not possible. So we have h as r by 3. This is our critical point. Now to find maximum minimum, we differentiate this again. Let's do it. So we have our f of h, f dash h, and h is equal to r by 3. This much we have calculated by now. Now let's find f double dash h to look for maximum minimum. So again, because r is constant, this is 0, minus 2h. Okay, it is minus 2. It is minus 2r because derivative of h is 1, and this will become minus 6h. So without putting the value of h, yet you can say that it is less than 0 because all terms are negative. So you have 1 by 3 pi and minus 4r. This is less than 0, and that is why f of h, which is showing the volume of the cone, is maximum. So that's the first part which we wanted to prove, that the volume is maximum. The second thing we want to prove is that the altitude is 4r by 3, that is the height of the cone. So from here We have h is r by 3, but the height of the cone is h is equal to h plus r. So, h is equal to, put the value of h and simplify this. So, that gives us that the height of the cone is 4r by 3. So, that was one more question from application of derivative. For more questions on the chapter and topics of mathematics, do subscribe to the channel and like the video, share it with your friends. Thank you.